What is this? What type of liquid is this? So many different types.
What you got going on here, Happy? What are you looking at?
I'm trying to figure out. I see all types of electrodes. I don't even know where they're for. Like they're different colors. I don't know where they. I'm wondering where they came from. But why is there like lettering in the corner? I see 6010. I see 6013. Then I see an E. What does E mean? What does the numbers mean? I see this big boy.
Hopefully it means easy, huh?
Hopefully.
Easy to run. Well, I see you've got a whole stack of different electrodes here. You got a whole lot of different types, you know. And you're right. It makes a person wonder, why do we have so many different types of electrodes? Why can't we just have one or two and be done with it? You know, it's really just not that simple. So your first thing we want to think about is, how in the world did these develop? Where did they come from? Welding, or the introduction of the electric arc, has been around since the early 1800s. Sir Humphrey Davy discovered the electric arc. But then after that, we didn't know much what to do with it. They couldn't do a whole lot with it. And then around the 1900s, the turn of the century, a man named Strominger and another man named Klevsberg, they decided to put some elements on the outside to see what it would do to the electrode to give it different properties. Okay. So that's why we've got different coatings on the outside of these electrodes.
I also have another question. What is this in the middle?
Well, that's your electrode itself. So we know from the definition of the word electrode, that just means that's what's going to transfer your electrical current from your welding machine to your workpiece. Okay, and then the coating around it is what's going to give us some different reactions, or different shielding action, I should say, to the weld itself. But each individual electrode has different properties and different characteristics in the steel itself.
Okay. How about if I remove the coating and I want to run my electrode holder? Would it run the same, or would it be a difference, or what is this?
Well, if you took the coating off and just ran it with a bare wire, then you're not going to have anything that's going to be able to shield the weld itself from things in our atmosphere, like oxygen, nitrogen, things that can really do a lot of damage to our weld and to the steel. So you just wouldn't have a good transfer at all of the material. It'd be very, very unstable and not clean whatsoever.
Okay. So I see there's a thinner one. It's a 6010. Can I use all of them the same to run a 3/8 plate, half inch, or what would you recommend?
Well, every one of these jobs every one of these rods has an independent job. So they all do something, and they're all made to do something different and give you better reactions, because welding conditions change. They go from being really, really clean to being really wet, rusty, dirty. Mm-hmm. You might be down in the mud. Some of this stuff just does not run in certain conditions. So that's why the people a lot smarter than us came up with different types of electrodes, so that we can be able to apply our work in a lot more different places. Now, we've got a lot of different electrodes, like we said, to do different jobs. And they run in different classifications. Now, you asked me about how they're designated. And we're going to throw up another picture of showing the people on screen all the number designations, so you can follow along at home too. But right now, whenever you see the letter E, that always is going to stand for electrode. And then we have 2, if not 3 numbers right before all the other information. Wow. This is called your tensile strength. On this one I have in my hand, this is a 6010. This one is a 7018. With this one being a 6013. This one here says 308L. We'll talk about that too. That's totally different than the rest of them. This has a NiCl, and it looks a lot different. So you can see that a lot of electrodes, if we don't know exactly what they are, they can be really confusing when you just run around some electrodes and pick one up to run it. You've got to know exactly what you have to be able to weld successfully. Otherwise, you're just going to have a big old mess. So, the first two numbers, if not three, are going to give us the tensile strength. Do you know what tensile strength is?
No, what a tensile strength is?
Well, tensile strength is the way they rated it. So if we had 1 cubic inch, 1 cubic square of this material, either 60-10 or 70-18 or 80-18, whatever it may be, that's the tensile strength that it's going to withstand as far as being able to be torn apart. It would take 70,000 pounds of pressure to tear this metal apart once it's been put in place correctly. Now, most of these electrodes have 4 numbers, and the number in the third position is always usually going to be a 1 or a 2. Now that gives you your position.
Okay.
So when you see an electrode that's got a 1 here, which every one of these do, that tells us that it can be used in every position that we need it to.
What type of position?
Well, of course, there's flat, horizontal, vertical, and overhead.
Oh, wow.
So some rods don't run well in anything other than flat and horizontal settings because the material or the alloy does not allow it to run well and out of position.
Okay.
Gravity has a hard effect on it. So a lot of these electrodes come in different types. You know, one number we haven't discussed is the very last one. Like we got a 60-10. The very last number is a 0. And then, like I said, we're going to throw up a chart for the people at home so they can see exactly what we're talking about on these numbers. But the very last number, like 60-10, 60-11, 70-18, all of these happen to mean something. Now, the very last letter or number, that's going to be your flux composition, the coating on the outside. It tells us what's comprising all of the protective material on the outside of this electrode. And each one of these takes on different properties. It's amazing what they have figured out to place onto this electrode to give it stability and run better. You know, for instance, a 60 series rod, you know, these are characterized by a lot of deep penetration. So you got 60-10s, 60-11s, 60-13s. Now, these are also classified as what they call cellulose type rods.
Which are these two? 60-13 and 60-10?
60-10, 60-11. Mm-hmm. Those 60-10 and 60-11, now those are cellulose. On the outside of that is cellulose, like 60-10, is cellulose and sodium. Cellulose is plant material.
Plant material?
You know, like leaves or just the body of a plant, just plant material in itself. So it's kind of amazing. You've got plant material or leaves and sodium, salt.
Wow.
Bringing on the outside of this material to give it its protective properties.
I didn't know that.
It's amazing, isn't it?
A leaf could make that in sodium and salt.
Yeah, just in sodium and salt only. Now, these, like I said, have a cellulose covering, a plant-based covering. Now, when you get into other ones like 70-18, then the 8 is going to give it a different classification. These are what we call low hydrogen rods.
Low hydrogen rods?
Mm-hmm. Low hydrogen basically means low water. Okay, low hydrogen iron powder. We don't want to have a lot of water in our area that we're welding, of course. And these run very well in very, very dry situations. Now, with that being said, low hydrogen electrodes, okay, so something that like a 4, I believe a 6 and an 8, I'd have to look at it to be sure, but those are low hydrogen electrodes, and those have to all go into a drying oven. Okay. So it's going to be at least around 200 degrees to keep the water out of all of your electrodes.
And how long do they last on the oven, the heating oven?
You know, you can put them in the heating oven and drying oven, and as long as you leave them in there nice and dry, they'll last almost indefinitely.
Cool.
Okay. Now, after we get them out, if you're working at a plant where it's very, very fracture critical, if a bridge or something could break and it means someone's life, if it does, then they are going to keep these under very close scrutiny. If you go up to the tool crib and you request some electrodes, they'll give you out just a certain amount. They'll log it at what time, and these have a time of exposure.
How long is the exposure?
Only about 8 hours maximum can they be exposed.
Wow.
So if you were working around a structural shop and you had some of these in your pocket and you were fitting things up and you ran past an 8-hour shift and these were out of the oven, then we need to take these back, put them back into the oven and grab new ones.
Okay.
But be advised, we can only rebake them one time.
One time?
Yeah, so don't grab too many electrodes that you're, going to have more than you're going to be able to run.
Usually, how much electrodes would you recommend to carry?
No more than a dozen is probably a pretty good number. A lot of places too, when you check out electrodes, they're going to keep a log of how many you've got, and then they're going to want that many stubbies back.
Oh, stubbies.
Yeah, the very last end of your electrodes. So when you're burning one of these up correctly, you should burn up the majority of the electrode and get into the numbers and letters down here on the end. Or in other words, only leave them about 1.5 inches, no more than 2 inches long, if we can help it.
That's good to know.
Yeah, these rods can be expensive. And the downside to what we call low hydrogen rods is that they're harder to run and they a lot of times end up with a lot more waste because they're very, very delicate rods. Now, every one of these electrodes has different properties about it. It does different things to the material. So when we have different jobs, we as professional welders, we need to keep in mind, I've got a rod to do whatever specific job I need to do. Like 60-10. It's characterized by deep penetration, a nice forceful spray, readily removable flux. So it may not seem to completely cover the weld bead, but it does. It really does cover it well. Now, the fillet welds usually have a flat weld face, but 60 series rods run, I would call, for lack of a better word, rougher. The surface is not smooth.
Why does it say pipe liner?
A lot of rods, some rods that are specifically designated to be run on pipe, they have a special alloy, which an alloy element is something that gives steel a different property. They'll have different alloying elements just for pipe. Maybe that pipe needs to expand, more ductility. But there's a reason they have specific pipe or specific electrodes for pipe, marked pipe liner.
Pipe liner.
Mm-hmm. They even have some rods, like 70-24s, that they can actually run downhill.
Downhill?
Mm-hmm. Which with a lot of our training when we're going through school, we always train to run from the bottom to the top, or what we call uphill. But on some applications, of course, there's a lot of almost every exception to most every rule. In some applications, they can run downhill.
Wow, I didn't know that.
But as regular professional structural welders, we'll always run from the bottom to the top. Now, don't be too scared if you don't know how or what they want these electrodes run like, because they're going to tell you.
Okay.
You'll either be given verbal instruction or on a welding procedure specification sheet.
So they won't throw me by myself and leave me by myself? There's always going to be somebody there with me?
Well, especially until you get some really good training.
Okay.
We're working on stuff that is really, really important. Either a bridge or a skyscraper. It could be anything. And of course, they're not just going to open the door and say, best of luck to you, buddy. But no, they're going to have somebody right there with you training so that you can make sure and do the right weld every time.
Cool.
The right application. Because we want to keep our trade up to standards. Okay? Now, the one thing we needed to keep in mind about all of these electrodes, like I said, they do different types of characteristics. Like the 60-10. They're frequently used for joining pipe, generally capable of welding in vertical positions, uphill or downhill. Okay, you can run those downhill too, but not as a common standard practice, only when told. And they run on what we call electropositive. We're not going to get into talking about currents today. We're just going to keep this all talking about electrodes. But on another video, we'll talk about different electrical currents too.
I'm curious, why is there different colors?
The color is not really super relevant. A lot of them will have real close to the same colors because a lot of your minerals are the same.
Okay.
The rod you have here, that's nickel. Okay, that's a nickel rod. That one there is good for cast. So that's going to have different protective elements on the outside. It's going to react differently. So every one of them has a different purpose. Like, let's say if we were working on something that was old or rusty, oily, ugly conditions, then a 6011 really works well in that type of application. It's versatile. It can work on AC or DC. A lot of people, like hobbyists and do-it-yourselfers, really like a 6011. Okay, they're usable with electropositive, and in joint penetration, it'll be noted it's going to be comparable to a lot of other rods and very, very strong. So the arc action and the fillet weld appearance are all similar to 6010. But the 6011 can really get the job done. If you're doing a lot of repair work, like at home, on the farm, 6011 is a really popular rod. And of course, they have electrodes, 6012, 6013s. You know, 6013s are mainly for like thin material.
6013s, like this one?
I like that one there specifically. You know, and for things that are not easy to fit together. You're not always going to have a real close fit joint. So sometimes you're going to have to jump over a few gaps here and there. So when we got gaps to fill up, we can grab what we call a good old gap rod. That 6013 right there will really fill it up good if you need to fill up some material. That flux covering makes the slag easy to remove and gives it a lot smoother arc transfer than the 6012. But also, the potassium compounds permit the electrode to operate with a low amperage and low open circuit voltage. So they react really well for home welders because we don't have access to high amperage at home. So 6011, 6013 is extremely popular.
So they will run what, on 120 volts? So 110?
You know, it's a really good question. The settings on our machines are going to be determined by the diameter of our electrode. For instance, you know, this is a 3/32 7018. Now we know from experience that, well, actually this is 1/8. I'm incorrect. We know from experience that these have a run parameters of 1 to 150 on the scale. This 3/32 doesn't run quite as high. I believe that scale on it is 80 to about 130. Now those are low end to high end. So we're going to find a sweet spot somewhere in the middle. So 7018, depending on the diameter, and you can look up the parameters, is what we call them, the parameters of these electrodes.
Where can I find the parameters?
It's so easy. Just go on any search engine. You guys are so lucky now because you have all this information right on the fingertips of your phone. We had to have a whole library before. But all you've got to do is just type into any search engine and it will type in exactly what you're looking for. 7018 run parameters, and it'll pop them up. So you can see exactly where to run at. Now they're going to give you a low range and a high range, and you're going to figure out the sweet spot to run that particular material. And then in some more videos, we'll talk about correctly run electrodes, what a bead should look like, and how to select the right voltage or amperage from that.
Oh, sounds great.
Right now, though, let's really keep in mind that a lot of these electrodes, of course, are going to be assigned for different jobs and different situations. That's why there's so many. There are literally hundreds, if not thousands, of different types of electrodes.
Wow.
You know, that's the incredible part about it.
How about this one? I never seen this electrode before. It's really, wow.
How would you like to be the poor guy that's got to run that?
Oh,
That's 7018 right there. That's a big one. What would you think that diameter is? About 5/16? Yeah, 5/16 or so.
5/16?
That's going to take a very large amount
Voltage.
of voltage to run that. You'd really have to crank your machine up. So it would be really great when we need areas of very, very good deposit. If you have some very big groove welds to make, then that would be very helpful. So of course, once again, they're going to make a rod applicable for your job. If you had very heavy plate, it would take a lot more runs with a thinner rod than it would with a bigger rod. So they're going to pick out the appropriate size rod for the job.
That's huge.
That is huge. They have some, SMAW, that are going to take up to 1,000 volts to run it.
1,000 volts?
They're 3/4 of an inch in diameter and about 3 foot long. And it's
pretty long.
It takes a guy with both hands to hold it and run it. It's incredibly big. So these electrodes, like we were talking about, they're used for a lot of different situations. And you've got to know exactly what the chemical is going to be doing in these electrodes so you can perform your job correctly. If you pick out the wrong rod and try to perform your work, if it's not correct, you're just going to be really frustrated and completely annoyed by what you're trying to do. Nothing's going to be successful. A lot of people don't realize that not only can we weld just steel, but you can weld a variety of different types of materials with electrode.
What type of materials?
Well, you can run, of course, regular steel.
Yeah.
You can run cast iron. This particular rod right here, what they call nyrod or nickel rod. Yeah, the old people call it nyrod.
Nyrod.
Yeah.
Sounds gnarly.
But that here's got a lot of nickel in it, so it's good for cast iron. So that would be a good cast iron rod.
Wow.
And then this one here, of course, this is marked 308L. And -16. So we're going to have some of the numbers after the main designations are what the hydrogen content is going to be or different properties that it's going to be capable of in the flux itself. Some have better absorption qualities, different things about the rod. And when we get into things like military aspects, then we have to really take a close look at getting the right correct rod because they hold things at a really high standard. But this rod can do stainless steel.
Stainless steel?
Mm-hmm.
Like coupons?
Well, no, like just regular stainless steel welding. If you had thick stainless steel plate to weld, you could weld regular thick stainless with that.
And that's 17654?
Well, right here, this is what we call 308L.
Oh, 308.
So 308 is going to be our stainless.
Okay.
Okay?
Cool.
So that's the type of stainless steel that you have. So once again, before not trying to get into anything about stainless steel, but we've got to match material to material. So of course they have a lot of different stainless steel electrodes. Now keep in mind, all of these are going to give off a lot of smoke. So with that being said, what would be the best thing for a person to do?
Use a respirator?
Yeah, use a respirator. Not only is it going to keep your face a lot cleaner, but it's going to keep you healthy. There's no telling what these electrodes are going to be doing to us. We have no idea 30 years from now what might happen to a welder, or maybe nothing. But why take any type of chances? Take all the precautions you can. So wear your respirator. You have no idea as a hobbyist until you become possibly a professional welder that some of these electrodes can be extremely toxic if you inhale them.
Oh, wow.
For instance, there's one here that's very cancerous causing if you're not careful. A stainless steel electrode, when we weld stainless steel, it gives off in fumes a substance called hexavalent chromium.
Hexavalent chromium? Mm-hmm. What is that?
Chromium-6. Hexavalent chromium is just a byproduct of when we are welding with stainless steel and it doesn't completely burn up. So anytime you have smoke, that's just an inefficient transfer of energy. So everything's not getting completely burned up. So you are actually breathing small particulates of dust, metal, whatever. That's why we should always wear our respirator when you're doing any type of welding. But now these give off a cancerous fume, a carcinogen.
Carcinogen.
Yeah. Now hexavalent chromium is extremely poisonous. It can cause a large variety of different types of cancers. And it's not a matter of if it will.
When it will.
When it will. If you are exposed to this for a long amount of time, it's positively going to give you cancer. There's no question about it.
Oh, wow.
So this is something we just don't play around with our health. You don't take chances, and you always wear the appropriate type of breathing apparatus. But this could cause brain cancer. It's extremely rough on ladies. It could cause breast cancer, uterine cancer, all kinds of ovarian cancer.
I'm like, oh man.
So you've got to be really careful when you just, take on a job. Make sure you know everything about what it is that you're doing.
So when we work in a job site, will they let us know what type of electrode, like what it could cost before we get a hold of them?
They're not probably going to tell you, be careful, this electrode will do this and this and this. Now, as professional welders or even a hobbyist, it's your responsibility to take care of yourself. Mm-hmm. So I don't like to rely on other people at all when it comes to my health. I want to make sure I'm doing the right thing. So look it up.
Okay.
When in doubt, just look up the information. Knowledge is power. So as long as you can understand or know about these electrodes, you're going to be a lot safer.
Cool.
So that's where we really want to make sure that we know exactly what it is.
I like the sound of that.
Just remember, all electrodes have different characteristics, different abilities to operate on different currents, either alternating currents, direct current electropositive, direct current electronegative. So there's a lot of things that we're going to have to take into consideration on another video when we start getting ready to run. But I just hope I've answered some of your questions that you had as to why we have so many different ones and what the letter designation means.
Yeah, actually, Roger, you helped me out a lot. I was actually confused. I was looking at each electrode and I was confused. I was like, man, what's this for? Like, I look at it like, I just see an electrode and numbers on there, and I was just really confused. I was like, okay, I think everything does the same thing, but you explained it very, very clear to me that we have to be careful and we have to read our numbers like a 60-10, 60-13, 60-12, 70-18, mm-hmm. And you also let me know about the tensile strings, the 70,000 tensile string, and I'm very happy to know this type of thing.
One thing I wanted to mention too, when we talk about our tensile strength, when it comes to things of the industrial type, most generally they will rate them right at the base level, the very lowest level that they can do. So we know that the 70-18 electrode will withstand 70,000 pounds of pressure on that weld. But we also, with that being said, that's not the maximum. This is the minimum that this will hold. Every electrode will give you different tensile strengths with a few thousandths difference variation depending on the flux coating. The same thing with some of your wire electrodes. If you have different shielding gases, that gives it different tensile strengths too. Wow. So they're always rated at the lowest amount of tensile strength available, so we can always give it the most strength and best job we possibly can.
Thank you, Roger.
Well, you're very welcome. Like I said, just remember, take care of yourself when you're running these. We have no idea what it's going to do to you later on. Hopefully, you're going to be doing this job for another 30 years. So take care of yourself. Use the right PPE. Look up all the parameters on your electrodes. If you have any questions, let's email me or direct questions. And remember, if you ain't burning, you ain't learning.
Oh, yeah. Sounds like that.